We're still in 4.3 day 1, and we have started talking about the trig ratios or the trig functions at any angle in the coordinate plane. Now we're going to shift gears a little bit here, do some definitions that maybe are a little different than what we've seen before with sine, cosine, and tangent, and then of course all their reciprocals. Is we're going to think about what if we're somewhere else in the coordinate plane. Up to this point, the only place that we've been is the first quadrant because all the numbers are positive. But there are going to be the possibilities of negative values for the sides of the triangles, except for one of them. The radius, or the hypotenuse, is always positive. So when you see this little formula down here, this is just kind of using the Pythagorean theorem, and what will happen is that this will always come out with a positive number. Now, the definitions that we have here, we're going to change some things a little bit with these triangles that we make. And we remember that sine was opposite over hypotenuse, but now you'll see that there are some different definitions here. We're talking y over r, x over r, y over x. And I want to tell you about the reasons behind those, why we can actually say that. And so to do that, let's look at this little diagram over here. Let's say that we have the point P, which is the coordinates x and y, whatever coordinates those are. Now, this one happens to be in the second quadrant, but we won't worry too much about that right now. We won't worry about negative numbers. But if this is x, y, that means that this side here is x, this side is y, and then we've got the hypotenuse, which you can see here is r. So r is going to be another way of saying hypotenuse in a lot of these cases. Now, if you're looking at this triangle and we're talking about this is our angle, now you might see that, well, this is the angle, the big one, but when we have, anytime we're doing trigonometry, we think about a reference angle. That's the angle within the triangle. So I'll be talking about reference angles, but we're going to use that to make things easier to visualize. So now that we have this, I want you to see up here that sine is y over r. Now, normally it's opposite over hypotenuse, but look at what we have. Y is the opposite, r is the hypotenuse. And so that makes sense here. The y and the r, that's just a replacement for opposite over hypotenuse. Same with cosine. Cosine is usually adjacent over hypotenuse. Well, adjacent in this case is x, hypotenuse is r, so x over r. Tangent is y over x because that is opposite over adjacent. And so these things right here, this redefinition of sine, cosine, and tangent, those are all just based on the fact that we are using x, y coordinates in this coordinate plane and that our hypotenuse is r because we're thinking about this as a circle. Now r, sometimes we'll need to find it. You can use this little formula here. It's just an offshoot of the Pythagorean theorem, so keep that in mind. Also note that I'm not really going to talk about these too much because, again, it's just flipping them. It's just flipping all these over and putting them into there. Now, this y not equal to 0, x not equal to 0, that business is just to make sure that it's not undefined. So you won't really be dealing with that a whole lot right now. But we're going to go into an example of this so you can see what that looks like. Here is that example. So what we've got, we're going to be taking a look at all the trig values for this angle when we use the point 4, -3. So it's in the fourth quadrant. Now when we make that triangle, we are going to again go to the horizontal axis. We have to go to the horizontal axis in order to stay consistent. So our reference angle is just right in here, and we're going to fill in these sides. So we've got x is 4. That makes this side of the triangle. We've got y is -3, so that's over here. And then the hypotenuse, or the radius, is going to be our third side. Now remember that the radius is always positive. We can find that out even by just plugging it in. We can say r equals square root of x squared plus y squared. So we would find this out anyway if we were to do all this. And what ends up happening is this one turns out pretty nice. This one turns out to be 5. So we've got 5 there. That's going to be our hypotenuse. but always keep in mind that the radius or the hypotenuse is going to be positive. Once we've got those set up, now it's pretty straightforward to find sine, cosine, and tangent and the other ones as we go. So let's do that. Sine. Now, as you're thinking about this, you're probably going to keep thinking opposite over hypotenuse, but you might want to start thinking about y over r for sine. But either way, that's going to be negative 3 over 5. Then cosine, that is going to be x over r, so that is 4 over 5. Tangent is going to be opposite over adjacent, or y over x, so that's going to be negative 3/4. And like before, as I've mentioned, we can do the other ones, the cosecant, secant, and cotangent by simply flipping the ratios from their originals. So negative 5/3, 5/4, and negative 4/3. And that gets us all 6 ratios for this point in our trig angles.